Hello everyone, welcome back. In the last video, you have studied what is a bearing and what is the definition of the bearing. And now we will go on to the classification of the bearings. Okay, the bearings are broadly classified into sliding contact bearing and rolling contact bearing. Okay, here you can see this is the sliding contact bearing, and this is the rolling contact bearing. Okay, in sliding contact bearing, the journal or the shaft and the bearing is separated by a thick film of lubricant. Okay, here the lubricant separates the journal and the bearing, whereas in the second one, that is rolling contact bearing, uh, there is a rolling type of relative motion between the inner race and the ball, or the rolling element. Here the journal is rigidly fixed to the inner race of the bearing. That is, there is no relative motion between the between the shaft and the inner race, but there exists a relative motion between the rolling element, that is ball, and the inner race, as well as ball and the outer race. Here we can say the outer race may be fixed. Okay, so this is a rolling type of bearing. Okay, now these rolling contact bearings are uh, further classified based on the rolling elements, that is ball, cylinder, and needle. And now coming back to sliding contact bearings, the sliding contact bearings are further classified into metallic and non-metallic, and again they are further classified based on the load, lubrication method, and the configuration. Okay, and now if we look into the load classification based on load, it is further classified into axial or thrust bearing and radial bearing. So now we will see what is axial and radial. Here you can see this is the bearing. Okay, this is the bearing. Here, if the load is acting along the axis of the journal or along the axis of the bearing, then it is known as axial bearing. Similarly, if the load is acting perpendicular to the axis or along the radial direction of the journal or the bearing, then it is known as radial bearing. If the load is acting in both the direction, then it is known as combined load, and we have bearings for this type of loading also. And now the next one is the classification based on configuration. It is classified into solid type and split type. Here you can see this is the solid type of bearing, where it is the bearing is of one full circle, it is one single piece, whereas in the split type the bearing is made of two halves. And the another classification is based on lubrication method, that we will see in the next slide. Okay, the next classification is based on the lubrication or methods of lubrication. Okay, the first one is thick film lubrication or thick film lubricated bearing, and thin film lubricated bearing, and zero film lubricated bearing, and hydrostatic or externally pressurized lubricated bearing. We will see one by one. First, the thick film lubrication. So here the thick film lubricated bearings are those in which the working surfaces are completely separated from each other by the lubricant. So this is the picture what you have seen earlier. So here the journal or the shaft and the bearing is completely separated by a thick film of lubricant. A thick film of lubricant. Okay, so such type of bearings are also known as hydrodynamic lubricated bearings. Okay, the next classification, that is thin film bearings. So here although the lubricant is present, the working surfaces partially contact each other at least a part of the time. So, and such bearings are known as boundary lubricated bearings. And further classification is zero film bearings. That is, there is no lubricant present. There is no lubricant. The bearing will operate without the lubricant. And the next classification is hydrostatic or externally pressurized lubricated bearing. Here, the lubrication is achieved by forcing externally pressurized lubricant between the journal and the bearing. So here you can see this is the journal, and this is the bearing. Okay, here see, when the journal is at rest, here this is the journal, it is not moving, and the second case is when the journal is at full speed. So here the lubricating oil is constantly pumped with the help of a pump, external agency, that is a pump. So this pump will pump the oil or lubricating oil um, in between the clearance or the gap between the journal and the bearing. The next topic is terms used in hydrodynamic lubrication. In the figure, you can see the hydrodynamic lubricated bearing, which consists of a journal and a bearing. Okay, so this is the journal and this is the bearing, and the gap between the journal and the bearing is filled with the oil. Okay, so and the load is acting on the axis of the journal. Okay, the load is acting on the axis, along the axis of the journal, not on the bearing. Okay, so first term, that is diametral clearance. Okay, it is the distance between the diameters of the bearing and the journal. Okay, here this is the journal and this is the bearing. So C is equal to D minus D, where uppercase D is the diameter of the bearing and lowercase d is the diameter of the journal. Okay, and next is the radial clearance. So it is a difference between the radii of the bearing and the journal. Okay, that is represented by C1. C1 is equal to R minus R or D minus D by 2, and that is equal to C by 2. It is half of the diametral clearance. Okay, next, diametral clearance ratio. It is the ratio of the diametral clearance to the diameter of the journal. So that is represented by psi. Psi is equal to C by D, and that is equal to D minus D by D. Okay, next is the eccentricity. Okay, here it is the radial distance. It is the radial distance between the center O of the bearing and the displaced center O dash of the bearing under load. Okay, if there is no load acting on the bearing may be positioned anywhere, but if the load is acted on the bearing, then it will get displaced. So eccentricity is the distance between the centers of the journal without load and with load. Okay, so that is the eccentricity, and that is denoted by E. And next is the minimum oil film thickness. So it is the minimum distance. It is the minimum distance between the bearing and the journal under complete lubrication condition. So here this H0 is the minimum oil film thickness. Okay, and next is attitude or eccentricity ratio. Okay, it is the ratio of eccentricity to the radial clearance, and that is given by epsilon. Epsilon, that is equal to E1 E by C1, and that E is the eccentricity, that is the radial distance between the center center O of the bearing and the displaced center O dash, and that can be given as C1 minus H0, where C1 is the radial clearance, that is the difference between the radii of the journal and the bearing, and H0 is the minimum film thickness. So that will give you the eccentricity, and here attitude or eccentricity ratio is it is the ratio of eccentricity to the radial clearance. So eccentricity E, that divided by C1, and that is equal to E is nothing but C1 minus H0. So C1 minus H0 by C1, so that is equal to 1 minus H0 by C1, and that is 1 minus 2 H0 by C. And next is the short and long bearing. So L is the length of the bearing and D is the diameter of the journal. So if L by D is less than 1, then it is known as short bearing. If L by D is greater than 1, it is long bearing, and L by D is equal to 1, then it is square bearing. So now we will summarize the terms used. Okay, so here the first term, that is the diametral clearance. It is the difference. It is the difference in the diameter of the journal and the bearing. And the next is the radial clearance. That is the difference between the radii of the journal and the bearing. And then diametral clearance ratio. That is it is the ratio of diametral clearance to the diameter of the journal, that is psi that is equal to c by d. And then eccentricity is the distance between o dash and o, where o is the position of the journal without the load, and o dash is the position of the axis of the journal with load. So it is the distance, eccentricity is the distance between o and o dash. And then the minimum oil film thickness, so it is the minimum distance between the it is the minimum distance between the bearing and the journal under complete lubricated condition. And then attitude or eccentricity ratio, it is the ratio of the eccentricity to the radial clearance.